We have an example problem here. A 25 millihenry inductor with internal resistance of 25 ohms is connected to a 110 volt RMS source. If the average power dissipated in the circuit is 50 watts, what is the frequency of the source? All right, so we have an alternating source that has an inductor and a resistor. Now I know it's just an inductor, but we can account for the internal resistance as if it were a resistor. Inductor is 25 millihenries. Our source is 110 volts RMS. Average power dissipated, that's going to be for the resistor. Dissipated meaning leaving the circuit. All right, so we know that's 50 watts. If we look at our equations for power dissipated by a resistor, they can be written multiple ways. I kind of like just the IRMS squared times R. We know the value of the resistor. We know the power, so we can use this actually to find IRMS. IRMS will be the square root of our power dissipated over the resistor value. So the 50 watts over R is 25 ohms. So the RMS current in the circuit will be the square root of 2. So 1.414 amps. We can relate this current to the source voltage. We know RLC, even though we don't have a C. Let's talk about that for a second. For an RLC circuit, we would say the current, the peak value of the current would be the maximum source voltage over Z. And we would say that Z is the square root of R squared plus the quantity of XL minus C, XC squared. Now we do not have a capacitor in this particular example, so it is totally valid just to leave the XC part out, not put 0 in for C, just leave out X sub C. There is no X sub C if there's no capacitor. This relationship for current, if you remember a previous example, if you watched it, these peak values, if we divide them by the square root of 2, they are now RMS values. We've calculated IRMS. We are given the RMS source voltage. So we can find Z. The frequency they're asking us about is going to be within the XL. We know XL is omega times L, which is 2 pi F times L. So if we find Z here, then we can work back and use this equation for Z. So we're just kind of working backwards. So our RMS voltage, source voltage, is 110. We calculated 1.414 amps for the RMS current. So we're finding Z is 77.78 ohms. Maybe I'll go one more decimal place since we have 3 sig figs in the problem. Okay, knowing Z, let's come back here. If we square both sides, I can bring the Z squared and the R squared together. And this will equal XL, which is 2 pi FL. I want frequency. So Z squared minus R squared square rooted over 2 pi L. We've calculated the value of Z. We were given the value of R. And we were given the value of L, which we do want to put into just henries and not millihenries. Okay, I'm getting, let me slide this a little bit. Getting 469. Well, I'm getting 468.899, which 469 hertz would be the frequency of the source in order to result in this specific power. So still using main equations. This one is different in that we leave out XC. XC is 0 if there's no capacitor. So that simplified Z to be the square root of R squared plus XL squared. And then worked back to find the frequency within XL.